Welcome. Let's go ahead and talk about quiz 10 over 9.3 and 10.1. Number 1, in a random sample of 40 dog owners enrolled in obedience training, it was determined that the mean amount money spent per owner was $109.33 per class, with a standard deviation of $12. Construct and interpret a 98% confidence interval for the mean amount spent per owner for an obedience class. First thing I'm going to do is go ahead and go through and label everything that I know. I know 40 is my sample size, so that's my N. It was determined that the mean amount based on the sample size, so my mean is my X bar and my standard deviation is my S, because they're based on that sample. Construct and interpret a 98% confidence interval. So since I already have something that's X bar labeled, I know I'm going to have X bar plus minus E is going to be my interval, my E. Now I'm going to go to my formula sheet. We are in chapter 9. I know that I'm using E. I have to figure out which E am I using here. Well, looking at my E's that I have, this one has P hats, this one has S, so therefore I know then I'm using this formula here to find my E. Now I know E is equal to my critical value times S divided by the square root of N. So E is equal to, I need to go to my critical value, and this is telling me that I'm using my T distribution. Since I'm using my T distribution, I do need to know my degrees of freedom. Here's my N, so my degrees of freedom is then 39. I'm going to go to my T distribution, 98% with my degrees of freedom 39. So I'm going to get 2.426. .426 times S, which is 12, divided by the square root of 40. So E is approximately, pull up my calculator, 2.426 times 12 square root. Rounding to 2 decimal places, like it says on your quiz, was 4.60. So my E is 4.60. My confidence interval is then X bar plus minus my E. So my X bar, 109.33 minus 4.6, and then add it. So when I'm writing this interval, it says write it as an interval. So writing it as an interval, 104.73 and 113.93. Our interpretation, we are 98% confident the population mean amount of money spent per owner for obedience class is between $104.73 and $113.93. Number 2, for the null and alternative hypothesis are given, determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed, and the parameter that is being tested. So given my hypotheses, I look at my alternative. This is pointing to the right. When I say this, I'm looking at my symbol that's right here. My symbol is pointing to the right, so therefore it is a right-tailed test, and my parameter is P. So my answer on my end was D. P hat is not a parameter. The only ones in 10.1 that you would be looking at would be mu or sigma. And in 10.1 you might see a sigma, but you wouldn't see it in 10.2 or 10.3. So it's either going to be mu, sigma, and then of course my P that's given here. Number 3. The mean credit card debt among households in one state is $8,400. A hypothesis test is to be performed to decide whether the mean credit card debt for households in a formerly affluent town of rich no more differs from the mean credit card debt for the state. So first thing that I see, the first sentence says mean is, so therefore my null hypothesis, which is always denoted with H sub 0 or H naught, it's called H sub 0 though when you're typing it, is mu is equal to 8,400. Then my alternative, so H1, and it's a sub 1 that's there. When you're looking at the last sentence, does it say anything about greater than? No. Does it say anything about less than? No. It just says differs. So when it says differs, it means not equal to. So then mu is not equal to 8,400. Which in my case, my answer here was C. Looking at these other examples here, I know that this one right here cannot be a hypothesis because my null hypothesis is not correct. For your null hypothesis, it always has to be equal to. So right away, I know this one is out. Same thing for A right here. My null hypothesis has to be equal to, so that's out. This one says H sub A. Sometimes you'll see that in examples, the alternative in some books and in some authors, it's H sub A. This one uses H sub 1 a lot more. All right, let's look at number 4. For the given hypothesis test, explain the meaning of a type 1 error, a type 2 error, or a correct decision as specified. In the past, the mean running time for a certain type of flashlight battery has been 8.2 hours. The manufacturer has introduced a change in the production method and wants to perform a hypothesis test to determine whether the mean running time has increased as a result. The hypotheses are. So check out the example of the hypotheses. My null hypothesis is equal to. Your null hypothesis is always equal to. My alternative here is greater than. And that's because it does say right here that the mean running time has increased as a result. So that is your alternative. Just kind of pointing that out for you. It says, now explain the meaning of a type 1 error. So my type 1 error, as soon as I see type 1 error, I write reject null hypothesis when true. That's what I always think of when I know of a type 1 error. So I write that. So now I go back to, in this case, my example that I have here, my hypotheses are already written for me. So that's what's kind of nice. If my hypotheses are not written for me, then I do need to write them. But these ones are already written for me. So I reject the null hypothesis when this right here is actually true. So that's actually what's true, but I rejected it. Now I look at the multiple choice. I will tell you that when it comes to a type 1 and a type 2 error, you will not know if you make a type 1 or a type 2 error. In the assessment, this will always be multiple choice. Okay, so it'll always be multiple choice. It's not something that you have to write. You will only see really the stuff about a type 1 and a type 2 error in 10.1. In a question, later on in a question in 10.2 and 10.3, they might say what would happen if you had a type 1 error or what would happen if you had a type 2 error. But this is the main section that you'll see it in. All right, so I'm looking at, going through and looking at my choices. A type 1 error would occur if, in fact, mu is equal to 8.2 hours. So that's the first thing I look at. So this says, in fact, so that means actually. So this one says, in fact, greater than. This one says, in fact, greater than. So I know that that one's not true. So then I'm going to go to this last one, and it says, in fact is equal to. So all of those right there, that part is the when true part. Now I'm going to look at the rest of the statement. It says, but the results of the sampling led to the conclusion that mu was greater than 8.2 hours. Then looking at D, it says, but the results of the sampling do not lead to the rejection of that fact. But what does this say right here when we're looking at a type 1 error? It says reject the null hypothesis. This says do not lead to the rejection of that fact. So therefore, that cannot be the true. It says, but the results of the sampling led us to the conclusion that mu is greater than. So what did we do? We looked at that our alternative was what our sampling led us to believe, which says we rejected the null hypothesis. Let's look at number 5. The mean pressure required to open a certain valve is known to be mu equals 8.2 psi. Due to changes in manufacturing process, the quality control manager feels that the average pressure has changed. The null hypothesis was rejected. First thing I'm going to write are my hypotheses, my null hypothesis and my alternative hypothesis. Going back to the first sentence, the mean is known to be, and it says right here, mu equals 8.2. So mu equals 8.2, which means now I have to figure out what my alternative is. Mu isn't going to change, and 8.2 is not going to change. So reading this sentence, it says that the quality control manager feels the average pressure has changed. Does it say greater than? No. Does it say less than? No. So has changed is then not equal to. If they don't specify, then it has to be that it's not equal to. Now, the other part that it gives me is that it says the null hypothesis was rejected. So we reject the null hypothesis, which means there is sufficient evidence to support that the average pressure has changed. When you reject the null hypothesis, you choose that there is sufficient evidence. If you do not reject the null hypothesis, then you say there is not sufficient evidence, and you're always supporting your alternative. So I know then this is out, this is out. So is sufficient evidence to open that has changed, has not changed. So my answer here is D, has changed. It's learning the language of the hypotheses test. You are going to have to be able to say what your interpretation is at the end. I've done that in several of the examples that came in the notes packet. And obviously, when you're on my stat lab, you're choosing the correct answer, but you have to make sure that you know how to write the correct answer. So if you reject the null hypothesis, you say there is sufficient evidence to support, and then it's whatever the alternative is. If you do not reject or you fail to reject, then you say there is not sufficient evidence to support whatever the alternative is. You always are supporting or not supporting your alternative. Well, you have a great week.